Hey everyone, and welcome back. Today we're diving into a pretty cool new way of thinking about AI
Oh, yeah.
called feasible learning.
That's a good one.
It is. And we've got this research paper fresh from a recent AI conference.
hmm
And it's got me thinking
Oh, yeah.
about AI that isn't just trying to be,
Right.
pretty good on average,
Yeah, yeah.
but actually guarantees
hmm
a certain level of performance for every single individual.
Yeah.
That's feasible. Learning in a nutshell.
It really is a different way to think about things.
So instead of like aiming for a B+ student who might be
Right.
failing a few subjects,
Yeah.
feasible learning is saying, hey, you need to pass every subject.
Yeah.
So can you walk us through what makes feasible learning so different?
Well, traditionally, we train AI using what's called empirical risk minimization, or
What is
ERM.
ERM?
And you can think of it like
Yeah.
an AI learning to bake cookies.
All right, I'm with you.
With ERM, the AI is trying to minimize the average number of burnt cookies across all the batches.
Makes sense.
So some batches might have more burnt cookies than others.
Okay.
As long as the average is good,
Right.
we're happy.
Gotcha. But with feasible learning, it's not about the average, right?
Right. Feasible learning, or FL,
Okay.
sets a limit on how burnt any single cookie can be,
Hmm.
regardless of the batch.
Oh,
So every cookie has to meet a certain standard.
interesting.
It's about ensuring a consistent level of quality for everyone.
Okay, I'm starting to see the difference.
Yeah.
So how does this actually play out in practice?
So the paper uses an example of polynomial regression.
Oh, what?
Imagine you're trying to draw a line that fits a bunch of data points.
Hmm.
ERM might choose like a really complex squiggly line
Okay.
that hits every single point perfectly.
Uh-huh.
But FL prefers a smoother line
Okay.
that captures the general trend without overcomplicating things,
Yeah.
even if it misses a few points.
I see.
So it's like saying, don't overthink it, keep it simple.
I'm looking at figure 1 from the paper right now.
Yeah.
And wow, the visual difference is really clear.
Yeah.
It really is. Like FL is telling the AI,
Yeah,
don't overthink it. Keep it simple.
exactly. And that's the whole idea behind functional regularization in feasible learning.
Okay.
It's all about finding a solution that works well without being unnecessarily complex.
So how does feasible learning actually figure out which data points are giving the AI the most trouble?
Right.
The paper mentions Lagrange multipliers.
Yeah, Lagrange multipliers.
Yeah.
Think of them like spotlights shining on the troublemakers.
Okay.
In the data set,
Huh?
the brighter the spotlight, the more attention the AI pays to learning from that specific data point.
Interesting.
So the AI is focusing on the tough cases.
The tough cases.
Yeah, and by addressing those difficult data points,
Right.
the AI can achieve a better overall performance for everyone.
Okay, I'm getting it.
Yeah.
But setting that acceptable loss threshold,
Yeah.
that epsilon they talk about,
Right.
sounds tricky.
It can be.
What happens if you set it too strict?
That's a good question.
Yeah.
If epsilon is too strict, the AI might not be able to find any solutions at all.
Mm-hmm.
But if it's too loose, you basically end up back at ERM.
Oh,
So finding that right balance is crucial.
so how do they handle that?
Well, the researchers developed a clever workaround
Okay.
called resilient feasible learning,
Okay.
or RFL,
RFL.
and it essentially introduces some wiggle room
Okay.
with slack variables,
Oh.
making the whole process more robust.
So even if the data is messy
Right.
or there's some inconsistencies,
Exactly.
RFL can still find a good solution.
That's the idea. It's about being able to handle those imperfections in the real world.
That makes a lot of sense. Now let's see how this all comes together with a real-world example.
Yeah.
The paper talks about using RFL for an age regression task
Uh-huh.
with the UTK-faced dataset.
Right.
Can you tell us about that?
Absolutely. In this case, regular FL struggled because the dataset had duplicate images with conflicting age labels.
Oh, wow.
Imagine having two photos of the same person,
Okay.
but one is labeled as 25 years old
Right.
and the other as 30.
Yeah, that would throw me off too.
It's confusing, right?
Yeah.
Well, RFL was able to cleverly navigate those inconsistencies
Wow.
and still achieved really impressive performance.
Okay.
If you look at Table 2 in the paper,
Okay.
you can see the difference pretty clearly.
So RFL is like saying, okay, I see there's some conflicting information here, but I'm going to find a way to make it work anyway.
Exactly. It's about finding the best possible solution even when the data is challenging.
Okay, this is all very impressive,
Yeah.
but I'm curious.
Yeah.
How does this benefit me in the real world?
Right.
What are the practical implications of feasible learning for someone like me?
Well, think about services that offer personalized recommendations,
Okay.
like a music streaming app.
Okay, yeah.
With ERM, the AI is focused on the average user, so you might get recommendations that are popular overall, but not really your style.
Ugh, yes. I am so tired of getting recommended the same top 40 hits,
Right.
even though I'm a total metalhead.
Exactly. With feasible, learning those algorithms could be trained to ensure that every user gets recommendations that are actually relevant to their individual taste,
Right.
no matter how unique or niche.
So finally, an end to algorithmic echo chambers.
That's the idea. It's about providing a personalized experience for everyone, regardless of their preferences.
I love it.
Yeah.
So is this all just theoretical,
That's a great question.
or are there real-world applications of feasible learning in action today?
That's a great question, and that's exactly what we'll dive into in the next part of this deep dive.
Oh,
We'll explore how feasible learning is already being used and what it means for the future of AI.
okay. Can't wait.
Stay tuned.
We'll be right back.
Welcome back, everyone. Before the break, we were getting into some pretty interesting applications of feasible learning.
Yeah, lots of potential there. So what are some areas where this is already making an impact?
Well, one area where I see huge potential is personalized medicine.
Oh, interesting.
Think about it right now, treatments are often based on averages, right? Like what works best for the average patient.
Yeah, that one-size-fits-all approach.
Exactly. But with feasible learning, we could tailor treatments to the specific needs of each individual patient.
Wow.
It's like moving from ready-made clothes to custom tailoring.
Okay, now that is a game changer. Instead of hoping a treatment works well enough for most people,
Right.
it's designed to work optimally for you.
Precisely.
Yeah.
And the paper highlighted another really interesting application
Yeah.
in recommender systems.
Oh, right.
We were talking about those frustrating music recommendations earlier.
Oh, don't remind me. I'm still getting Taylor Swift suggestions, even though my playlist is pure heavy metal.
Right. With feasible, learning those algorithms could be trained to ensure that every user gets recommendations that are actually relevant to their individual taste,
Okay.
no matter how unique or niche.
So finally, an end to algorithmic echo chambers.
Exactly. It's about recognizing that everyone has different preferences and needs.
Right.
And making sure AI systems cater to those individual experiences.
I'm really liking where this is going.
Yeah.
Now, the paper also mentioned social media algorithms.
Uh-huh.
Things can get pretty heated online.
Oh, yeah.
And I've always wondered if AI could play a role in making those interactions healthier.
It's a really important point.
Yeah.
Right now, a lot of those algorithms are optimized for engagement,
Right?
which can sometimes lead to the spread of misinformation or negativity.
Yeah, sometimes it feels like the algorithms are designed to keep us hooked,
Mm-hmm.
even if it's not good for us in the long run.
Right. But with feasible learning,
Okay.
those algorithms could be trained to prioritize things like accuracy,
Yeah.
fairness,
Mm-hmm.
and even user well-being.
So instead of just feeding us whatever keeps us clicking,
Yeah.
the AI could be designed to actually encourage positive and constructive online interactions.
Exactly. It's about aligning AI's goals with human values.
This is great. Now, you mentioned earlier that this is still a relatively new area of research.
It is.
Does that mean there are limitations or challenges to using feasible learning in practice?
Yeah, that's a great question. As with any new technology, there are always challenges to overcome.
Of course.
One thing the researchers highlighted
Yeah.
is the difficulty of setting those constraint thresholds.
Okay.
Those epsilons we discussed.
Yeah, finding that sweet spot between being too strict and too lenient.
Exactly, can be tricky.
Yeah.
And they also pointed out that the choice of optimization algorithm can have a big impact on the types of solutions that feasible learning finds.
Interesting.
So there's definitely more work to be done in terms of refining those aspects.
So even though feasible learning is still in its early stages, it sounds like there's already a lot of potential.
Oh, definitely.
But what about those Lagrange multipliers we talked about earlier?
Right.
Do they have any practical applications beyond just helping the AI learn?
Absolutely. Remember those multipliers act like a spotlight on the troublemaker data points?
Uh-huh.
Well, it turns out they can also provide valuable insights into the AI's internal decision-making process.
Ooh.
It's like peeking under the hood
Okay.
and seeing how the AI is thinking, so to speak.
So we can actually understand why the AI is making certain decisions.
Yeah.
That sounds incredibly useful, especially if we're concerned about things like bias or fairness,
Exactly. For example, the paper described how high multipliers helped identify images that the AI found particularly difficult to classify.
like those blurry images or pictures of the same person with different age labels.
Precisely. And by analyzing those multipliers, researchers can gain a deeper understanding of the AI's blind spots
Okay.
and potentially improve its performance.
So instead of just accepting the AI's output,
Yeah.
we can actually understand the reasoning behind it.
That's right. And that level of transparency is crucial,
Yeah.
especially as AI systems become increasingly integrated into our lives. It's about building trust and accountability.
This is amazing.
Yeah.
So expert speaker, I'm curious to hear your personal take on this.
Yeah.
What excites you most about feasible learning, and where do you see it making the biggest impact in the future?
You know what really excites me?
What's that?
The potential for feasible learning to bridge the gap between AI and human values.
Okay.
It's about designing AI systems that are not only intelligent,
Uh-huh.
but also ethical,
Right.
fair, and beneficial to society as a whole.
That's a great point.
And that brings us to the big question we'll explore in the final part of our deep dive.
Okay.
What does this all mean for the future of AI?
All right.
Stay tuned, folks.
Welcome back to the final part of our deep dive into feasible learning.
Yeah,
We've covered a lot of ground,
we have.
from the fundamental shift in how AI learns to the exciting possibilities it opens up.
Yeah, definitely a lot to think about.
But now I'm curious about the big picture.
Okay.
What does feasible learning mean for the future of AI as a whole?
That's the big question, isn't it? We've touched on some specific applications,
Yeah.
but I think feasible learning has the potential to fundamentally change how we think about AI's role in our lives.
So it's not just about better recommendations or more personalized medicine.
Right.
It goes deeper than that.
Much deeper. Remember how we discussed those social media algorithms and the potential for feasible learning to create a healthier online environment?
Yeah, I'm still thinking about that. It's almost like feasible learning could help AI grow a conscience, so to speak.
Yeah, that's a great way to put it. It's about designing AI systems that are aligned with our ethical principles
Right.
and societal goals.
Yeah.
Not just chasing metrics or maximizing engagement, but actually contributing to human well-being.
And that alignment becomes even more critical as AI becomes more powerful and more integrated into our lives.
Definitely.
Imagine self-driving cars,
Yeah.
AI-powered healthcare financial systems.
Right.
It's a bit daunting, to be honest.
It is. But feasible learning offers a path towards building trust and ensuring that those systems are truly working for us,
Yeah.
not against us.
Right.
By focusing on the needs and experiences of every individual, not just the average, it creates a framework for AI that's accountable and responsible.
So it's not just about making AI smarter, but also making it wiser.
Exactly. And this idea extends beyond everyday applications.
Okay.
Think about scientific discovery.
Okay.
Imagine applying feasible learning to problems in physics, biology, chemistry.
Uh-huh.
Instead of just fitting models to the majority of the data,
Right.
we could identify those outliers,
Okay.
those anomalies that might hold the key to groundbreaking new insights.
So it's like feasible learning is giving us a new lens to look at the world,
Yeah.
one that embraces complexity and diversity.
That's a great way to think about it. And as we venture into the uncharted territory of artificial general intelligence,
Right.
this perspective becomes even more crucial. We need to ensure that these powerful systems are aligned with human values and goals, not just their own internal logic.
That's a sobering thought.
It is.
It makes you realize that the future of AI isn't predetermined.
Right.
It's something we have to actively shape.
Absolutely. It's up to us to define the values and principles that will guide the development and deployment of these technologies. We need to have those tough conversations, those philosophical debates about the role of AI in society.
It's a lot of responsibility,
It is.
but also incredibly exciting. We're literally shaping the future right now.
We are. And I truly believe that feasible learning can be a powerful tool in that process.
Yeah,
It gives us a framework for designing AI that's not just intelligent,
right.
but also wise, compassionate, and beneficial to humanity.
Well said. This has been an incredible deep dive.
It has been fun.
Thank you for sharing your insights and expertise.
You're welcome.
And for all of you listening, I hope this has sparked some curiosity and maybe even a bit of healthy concern.
It's definitely a topic that deserves our attention.
Indeed. If this deep dive has inspired you to learn more, be sure to check out the show notes for links to the research paper and other resources. And as always, keep learning, keep exploring, and keep asking those big questions.